All right, so what we're looking at now is taking our information, our knowledge of trigonometry, and applying it to word problems. Now, here's the catch, and this is every grade, every math class that I ever teach. Word problems are always the hardest because you're taking some English and you're turning it into math, and that is going to be our first step. After that, everything else we're going to do is the same, but it's taking these words and making it something that we understand or something that we're used to working with, a nice diagram, and then solving it, doing the math. So again, it's always when we're mixing English and math together, there's always an issue. All right, so what I want to do with these couple of word problems that I'm going to go through is some of the tricks, some of the how I go about solving a word problem. First thing is, generally for me, I end up, because I'm a math teacher, not very good with the English when I was younger, is reading the problem, all right? I read it once, and then I kind of go through it sentence by sentence to get the information. All right, so my example one here, two people are playing paintball, all right? One of the people is able to shoot the other from the top of a castle. Now, the person who shot the pellet is 175 meters tall. Can see the person they shot, who's a little bit taller here, at 190 centimeters, with an angle of depression of 38 degrees. Now, if that pellet traveled 50 meters, how high is the castle? All right, so I've read the question. I kind of grasped what is going on here. We got a paintball situation going on here. We got a person who's up in a castle, at the top of the castle, and shooting someone down below. All right, so now I'm going to try to draw that picture. Remember, I'm a math teacher, not very good with the art. So here we go. But I am going to draw a little simplified diagram. All right, so first off, I got nice level ground. All right, now I'm going to draw my castle in here. There we go. There's my castle. Now, this person here, well, we got one person up here. There we go. Now we got another person down there. Now, the person who shot the pellet, that's 175 centimeters. They're tall, that tall. All right, the person down here, they're 190 centimeters. All right, now, the one person, we'll pick right here, we'll pick a different color. This person here shoots the pellet and gets that person. Headshot. All right. Now, the question is here is, let me see. The person they shot is 190 centimeters. Okay, now, so I've dealt with the 190 and the 170. Now, it says they shot him with an angle of depression of 38 degrees. Here's what an angle of depression means. Is that when this person here at the top is looking down, or just looking straight across, that is considered a 0-degree angle. That is a normal sight line, that line in red. When you're looking at an angle of depression, that is referring to looking downwards, depression down. And so this angle right here is 38 degrees. So the red line is a 0-degree line, and because depression, you're looking downwards, it's 30 degrees down from that red line. All right, now, if the pellet traveled 50 meters, how high is the castle? So this blue line here, that is our 50 meters. And what we want to know is the combined height of our castle. We want to know how high that castle is. Now, again, trigonometry, we're dealing with right-angled triangles. So I have a right-angled triangle here. All right, I draw in here, and again, our castle is straight up, so there's our 90-degree angle. Now, what I'm going to do is, now that I've drawn my diagram, is I'm going to take this triangle and I'm going to shift it over, and without all the nice drawings in there. All right, so I take my right-angled triangle here, and I draw it over. So it represents something that I'm used to solving. Now, this line right here, that's 50 meters. In a way, we want our h, which is this height right here. Well, we want the full height, but we're going to deal with that after. But we want to find this distance right here on our triangle. I'm going to call it d. because the height is the entire height of the castle. All right, we're going to find this little line right here, or this full line right here, and then we're going to do some adjusting. All right, so because we want to figure out how high this castle is. All right, now 38-degree angle. Again, that is in here. Hopefully you can see it in my diagram. Now a full 90-degree angle, because I want angles that are inside this triangle. That 38-degree angle is not inside the triangle. Now this corner, this is from grade 9 math, is 90 degrees. So if I subtract 90 from 38, I'm going to get my angle in here. And so, because again, this whole corner is 90-degree angle, it's 38 right here. I want to find out the angle inside my triangle. And so when I do that, I get 52. All right, now, so if it's 52 in here, now I can solve for D. Again, I'm going to follow the same steps that I've been doing before. I know my angle's theta, so I'm writing down my given information. It's 52 degrees. That's the angle inside the triangle. Now, again, across from my right angle, that's the 50. That, because it's across from my right angle, is my hypotenuse. All right, and now this side D that we're trying to find is we're finding a distance here, a length. Let's see, that side is beside the angle. So that would be my adjacent. All right, now I have to now figure out which trig ratio I have to use. Again, sine on highway, on, I don't have the opposite, so that's not happening. Cosy at home. I do have the adjacent and the hypotenuse, so that means I'm going to use the cosine ratio. Whoops, get my pen there. All right, so I'm going to write that down. So I have cos theta. Again, cosy at home, the adjacent, divided by the hypotenuse. Whoops, hypotenuse. All right, I'm going to substitute my information in. So let's see here. I got cos 52 degrees. Again, the adjacent's on the top. That is my D value here. All right, and my hypotenuse is 50. All right, so again, this is where in my calculator I hit cos 50. Got to make sure it's in degree mode. All right, so if I hit cos 52, I get, let's see here, 0.61 equals my D over 50. And again, this is from last week where I now create, on purpose, a fraction equaling a fraction. Because when I have a fraction equaling a fraction, I can cross multiply and solve. So I have D times 1, well, that's just a D. And then I have 0.61 times 50. So 0.61 here times 50. And now 0.61 times 50 is going to be, let's see here, 30.5. There we go, and that's our distance. Now, here's the trick. When I go back to my diagram, I want the height of the castle. What I found was this piece here. So the distance, I'm going to have to do a little bit of an adjustment here. Now, the other thing is that see how these 175 and 190, they're in centimeters. My 30.5 is in meters. So I'm going to flip this because I have to have them all in the same units. I'm going to convert centimeters into meters. All right, so 190 centimeters, to convert centimeters to meters, you divide by 100. And so 190 centimeters is in fact 1.9 meters. Our 175 centimeters is going to be 1.75 meters. All right, so now I have them in the same units, but I still have to figure out the height of this castle. All right, so the height of the castle, first off, I have to add 1.9 meters because that's missing in my diagram. Right? The person's taken into this, a person's account, or taken their height into account. All right, plus I'm going to add our distance here, which was the 30.5 meters. But inside that distance, that D, was this person's height, which I don't want. I just want to know the height of the castle. So I am going to subtract this person's height the person at the top, which is the minus 1.75 meters. All right, so I had to add this person's height to take into account that we're missing this piece, but I'm also subtracting this person's height to account for the fact that they're standing on top of the castle. And then when I finally do all that math, I take 1.9 meters plus 30.5 meters minus 1.75 meters, and it turns out that our castle is in fact 30.65 meters high. So a little bit of a different thing there where we had to do some adding and subtracting because our diagram's not quite, the triangle's not quite the distance or the height of our castle. So we had to do a little bit of rearranging there. And again, always making sure that you're in the same units. All right, so we had to convert those heights. All right, a little tough question there. Lots going on there. All right, I'm going to try one more word problem. So this would be example 2 with the 2 buildings beside each other. All right, I'm not going to write it all out because I think I'll probably fill up the board. All right, now. So again, I like to read my problems. And so a person in a short apartment building wants to know the height of a taller building 60 meters from hers. The person uses an angle of depression of 43 degrees to see the bottom of the taller building, but yet an angle of elevation or inclination of 58 degrees to see the top. What is the height of the taller building? Okay, so again, here's what I've got going on. I'm going to draw it out here first. I've got 2 buildings, and I've actually drawn those, put those in there. So there's my big building. And let's put my shorter building right here. Little decorations, give them a door. Big taller building, so we'll put a couple more windows in here. All right, so there's our 2 buildings. So I've read the question. Now again, I'm going to reread it so that I can fill in the information in my diagram and then again pull information from that. Now, so I'm just first sentence here. A person in a short apartment building. So again, my artistic skills are limited, so I'm going to put this person here as a red dot. There's my person. All right, wants to know the height of this taller building that is 60 meters from hers. So this distance right here is 60 meters. All right, so there's my first sentence, getting the information down. Now, the second sentence, the person who's in the short building here uses an angle of depression of 43 degrees to see the bottom of the taller building. So I'm going to stop right there. Again, there's those words, angle of depression. So this person looking straight across, there's your 0 degree angle. But they are looking downwards here and with an angle of 43 degrees right in there. That would be our angle of depression, looking downwards. Now, they're also using an angle of inclination, which is also another word for inclination, incline, looking upwards, or elevation, you're elevating, looking upwards, of 58 degrees to see the top. So they look upwards. Now again, from that middle line, that's our 0 degree, right in here is our 58 degrees. All right, so that would be your angle of inclination, looking up, or angle of elevation. 2 words there that you could use. And again, the last sentence says, what is the height of the taller building? All right, so we have a diagram here. Now, the 2 angles in here, we have a 58 degree and a 43 degree. If you add them up, they do not give us a right triangle. So we actually don't even have a right triangle here. But we do have, we can split that triangle up into 2 right angle triangles. All right, so I'm going to split this thing up where this is triangle number 1 right here, and this is triangle number 2. Now, if I look at triangle number 1, again, I'm just going to take it from my diagram and bring it over. There it is. I have my 58 degree angle inside here. I have this distance 60, which is the line from here to here. So there's my 60 meters. I'm going to put a right angle here because the building is staying straight up. All right, so there's the information that I have in my first triangle. My second triangle down below, there we go, and again, our building's right angles. This is my second triangle. All right, angle of depression is 43 degrees right in there. And again, our 60 meters, if I moved it up, it would be right here. All right, so there is our two triangles. Now, I want to find the height of this building. But because I'm breaking that triangle into two pieces, I'm going to break the height into two pieces. I'm going to call from here to here X, and the second part of the building Y. So on my first triangle, there's the X, and on my second triangle, there's my Y. All right, so I've broken my height up into an X and a Y because I broke my triangle up into two right-angled triangles. So once I find X and Y, I put them together and I've got my height. All right, so again, now that I've taken my example, drew a picture, and now I have, well, this time I've got two trigonometry problems. All right, so again, I do the same method I've done before. Write down my information. So I know on this first triangle, I have a 58-degree angle. Let me see, the side across from my right triangle, that's the hypotenuse. I don't have it, but I do, well, the side across from my angle is X, so that is my opposite, is X. And that would then make my 60 here the adjacent. So now that's my first step. I wrote down my given information. Now I'm looking at what trig ratio do I have to use. So again, I use my memory sign on highway. No, don't have the H. Cozy at home. Again, I don't have the hypotenuse, but I do have tan on arms. So tan ratio is the one we need. So I have tan theta, again, tan on arms, opposite, divided by the adjacent. All right, I'm going to sub my information in. So I have tan of 58 degrees is equal to, again, make sure I get everything's in the right order here. My opposite's on the top, my adjacent's on the bottom. So I have tan 58 degrees is equal to X over 60. Tan 58, again, I can type that into my calculator, and I get 1.6. All right, so again, I'm going to use my trick where I do create a fraction equaling a fraction. I do that by just putting a 1 in my denominator, because again, any number divided by 1 is just itself. All right, and then I do that so I can cross multiply. So 1 times X is X, and then I got, well, 1.6 times 60 will be my X value. And what am I getting here? 1.6 times 60, it's a whole number of 96. So that's just this part here is 96 meters, whole building. All right, now I'm going to go over and find my Y. All right, so my Y value, let's see here. Again, doing the same things. I've got my theta. It's 43 degrees. Let's see here. I don't have my hypotenuse again. Going across, though, there's my opposite. So Y is my opposite. It's across from the angle. And then, well, that makes my 60 the adjacent again. And lo and behold, we have the opposite and the adjacent again. So I know I'm going to use the tan ratio. All right, so I have tan theta. Again, tan on arms, opposite, divided by the adjacent. All right, I'm going to substitute in my information. So it's in here, tan 43 degrees. Opposite, that's our Y this time. And the adjacent is our 60. All right, so now I get my calculator out, type in tan 43 degrees, and I get 0.93. And again, here's a situation where, again, I'm going to create a fraction equaling a fraction so that I can cross multiply. And so 1 times Y is just a Y. And then 0.93 times 60. All right, that'll give us our Y value. So let's see here, 0.93 times 60, I get 55.8. And again, going back to our original diagram here, H, that's when we combine X and Y. All right, so therefore H is equal to, take my 96 there that I got for X plus my 55.8 that I got for Y. And I'm going to get 100 and something. Let's see here, 151.8. And the units are meters. And that is the height of our building. Which, if I was in class, we would actually do this. We have looked out the school window and we do figure out the height of a building across from us without even leaving the room. It is possible to do. Unfortunately, virtually, we're not able to do that. But there's, again, is an example. I'm trying to throw different tricks in you. Terminology, again, with the angle of depression. There's also looking upwards, which can be called the angle of inclination or the angle of elevation. Those words of looking up, but again, straight across is your 0-degree angle. In this case, we had a triangle that we had to, wasn't a right triangle, but we were able to split it up into two right triangles, find two different lengths, and combine them to find our answer. So again, I just wanted to go through a couple of examples with you, word problems. There is several different types, but I want to get some of the language down and also some of the tricks of subtracting distances or adding distances, or even, you got to watch out for making sure your distances are in the right units. All right, so later today, let's hit stop here.